Welcome friends. As we were discussing in our last session that there are variety of situations where upstream supply chain partners, they need to do inventory management based on this dependent inventory concept, where we discuss that they need not to forecast, rather they should not forecast for their own items requirement. The forecasting is done only at the final product level, which is done by the OEMs, and then based on that forecasting which is done at the OEM level, we do backward calculation, black flushing, which is going to help us in knowing the demand of our products, and also when we are going to start the production, when we are going to deliver the items to the subsequent stages of the production process. We discussed that for developing MRP1, there are three very important inputs. One is our master schedule, second is bill of material, and third is inventory records. With the help of one example, simple example, in our previous class, we discussed the case of product structure, and we also calculated that how bill of material is prepared using that simple product structure. It is a graphical way through which we can understand that for making one A, how many B's and how many C's, and B's and C's are further made using D's and E's. So, for one A, how many D's, how many E's you need to finally produce, and then these D's and E's will make your B's and C's, and B's and C's will make your A. So, a complete backward planning is required, which is dependent on the number of how many A's you need. And therefore, if all these B, C, D, E manufacturers, they also start doing their own independent forecasting, independent inventory managements, it may create either huge amount of inventory piling up in your system, or there may be continuous shortage of items in your system. So, with this MRP kind of systems, you are going to have a very efficient inventory management, which is not only going to help you to deliver the items at the promised dates, and also keeping the cost of inventory in check. Now, in this particular class, we will see that how are we going to do this entire MRP development. Now, for that purpose, as we already discussed, there are 2-3 very important inputs: master schedule, bill of material, etc. And then we are going to do the MRP processing with the help of some example. Now, this is on your screen is simple let us say table which gives you your master schedule. Here you see that any end item, when it is to be produced, when they are needed and in what quantity. So, we are talking three very important things, like item X, when it is going to be started. So, if I am going to deliver in period number 6, this is the delivery time. So, assembly starting, start of assembly is happening in the 5th period. To start the assembly in the 5th period, the fabrication is starting in the 3rd period and fabrication end in the 4th period, so that in the 5th period assembly can start. And similarly, the procurement of these items which is required for making this item X, may be some kind of a raw material, the processing will start, procurement will start, let us say order placed in period 1, order is received in period 2. So, when I have to deliver in the 6th period, I have to deliver in the 6th period, but I have to start the work in the backward manner from period number 1. When I am placing the raw materials order, the raw material is procured, is delivered in the 2nd period. In the 3rd period, I am starting the fabrication. 4th period, the fabrication is over. fifth period we are starting the assembly, assembly will be completed in the sixth period, and then I will deliver the item in the sixth period. So, this is one you can say dimension of our, which is the time dimension. And second important dimension, second important aspect will be quantity. How many? Because as you remember in our previous class, we discussed that we need one A, and for one A we discussed that certain number of B's and C's are needed, and for B and C also this B requires C and D, and this C requires D and E. So, in fact, the calculation, if you remember, for one A you require 14D and 10E, and these 14D and 10Es are making 14D and 10E for 2B and 3Cs, because 2Bs and 3Cs are needed for making 1A. So, this entire calculation we have already discussed in our previous class. So, after this master schedule, based on this knowledge of product structure, we are going to make a bill of material. This product structure tree PST is like this, which we have already discussed. Here we have a slightly more longer product structure, where you have 4 labels. This is one label, second label, 3 label, 4th label. In our standard language, these are labels. Which is the final product. Then these are sub assemblies, components and the materials like this. And you see that for making one final product, you require 2 sub assemblies, S1 and S2. S1 is 1 unit and you require 2 units of S2. For 1 unit of S1, you require 1 unit of C1, 4 units of C2 and 3 units of C1. Similarly, for 1 unit of S2, you require 2 units of C4, 2 units of C5 and 1 unit of C6. And for 1 unit of C6, you require 5 units of M6, 1 unit of C5, you require 1 unit of M5 and so on. Now, you can easily make these calculations based on what we have discussed in our previous class, that 1 unit of P1 requires 1 S1 and 2 S2. 1 S1 requires 1 C1, 4 C2 and 1 C3. Now, you see that 1 C1 requires 1 M1, 4 C2 will requires 4 M2, 1 C3 will require 1 M3, 2 S2 requires 2 C4, 1 C2 requires 2 C4. So, 2 S2 will require 4 C4. It will require 4 C5 and 2 C6. Now, 1 C4 requires 1 M4. So, 4 C4 will require 4 M4. 1 C5 requires 1 M5. So, 4 C5 will require 4 M5 and 10 M6. So, in this way you understand, for making 1 P1, you require 1 M1, 4 M2, 1 M3, 4 M4, 4 M5 and 10 M6. That is the total product requirements or material requirement for making 1 unit of product final end product, that is P1. So, this is a bill of material, that how many different types of sub assemblies, components, materials you require for making your final product. and accordingly this product structure tree is a very useful way, direct way, visual way of determining this quantity. Now, the third important thing in this, the processing of MRP. Now, for processing of MRP, we need to see the time phasing and we need to spread this over a sequence of spreadsheet sections. For example, we need to see what is the gross requirement of each component. Like I just calculated the gross requirement of each component. Now, if I say that I want to make 100 P1, if I want to make 100 P1, you will see the gross requirements will change, will be multiplied by 100 for all of these different sub assemblies and components and material parts. So, gross requirement, then timing of order release. Timing of order release is basically on the basis of lead time and available inventory. And then we need to also decide what should be the quantity that we will be discussing in our next class, that what should be the order quantity whenever you are releasing a order. There may be different types of system. In this class today, I am going to consider a system which is the simplest, that how many quantities you require, you order that many quantity, but that may not be economical. So, we will discuss in detail the determination of the batch size for ordering purpose, that because there is a cost element associated in this, and that is going to be discussed in our next class. Now, we have gross requirements, how many are in pipeline, and based on that whatever you have in house plus in pipeline, and on the basis you will get your net requirements, your gross requirement minus you have projected on hand, and then on the basis of that you are going to have your planned order release and their appropriate receipts on a particular day. Now, consider this example again, which we were discussing few minutes back, that we have this product structure diagram and 50 units are to be completed in week 8, 50 units in week 8, that is our commitment. Now, for this purpose we have to decide that how many orders we need to release when, and as I said, I am assuming few things at this moment, and what I am assuming that there is no inventory in the of P1 or any sub assembly in the stock. There is no inventory of P1 and any sub assembly in the stock. 50 P1 to deliver in week 8. 50 P1s we need to deliver in week 8, and let us assume that there are S1, S2, then we have C1 to C6, and then we have M1, M2, M3, M4, M5, M6. Now, we need to have some assumptions, means in reality you will have actual data, but here I am assuming some lead time. Let us say the lead time for these items are 1 week, every item is requiring 1 week, 1. So, for the simplification I am considering 1 week lead time for all these different assemblies, subcomponents, etc. And as I said, we will have this requirement for one P1 you require one M1. So, for 50 you require 50, for 50 you require how many M2? 50 into 4, 200 M2, 50 M3, then let us see how many M4, 4, 4, 10, 200, 200 and 500. These are the number of units which we require for M1 to M6. Because you want to deliver these items in the 8th period for P1. So, here you want to 8th period, then comes you can only deliver in the 8th period when the items are ready with you, and for assembly of P1 takes 1 week. So, to deliver in the 8th period, you have to complete the assembly by the 7th period. So, 7th period assembly P1. For getting assembly done in the 7th period, you need to get the S1 and S2 delivered to you in the 6th period. So, you will get the delivery of S1 and S2 in the 6th period when you have released the order in the 5th period. Order release for S1 and S2 and then S1, S2 delivered. And then you will use this S1, S2 in the 7th period for the assembly. And the quantity of S1, S2 which you need 50 S1 and 100 S2, 50 S1 and 100 S2. Now, S1 and S2 will only come when they have their components, and so 4th period, rather 3rd period, order release C1 to C6, 4th period C1 to C6 delivered. C1 to C6 are also taking 1 week, and C1 to C6 we know in how many quantities we need. You have 50 C1, 200 C2, 50 C3, 50, 200, 50, then C1 to C3 and C4 to C6 will also come 200, 200 and 100. So, these number of C1 to C6 you have to release in the 3rd week. Now, for getting C1 to C6 readily available for using in the 3rd week, they will only come when you have M1 to M6 available with you, and M1 to M6 you need to release in the 1st week, so that in the 2nd week you can have M1 to M2, M1 to M6 order release, M1 to M6, and the quantities are like this, and M1 to M6 delivered. So, in this sequential manner, when I am releasing the order for M1 to M6 in period 1, then M1 to M6 are delivered in period 2, and then the order for C1 to C6 is placed in period 3, so that C1 to C6 are delivered in period 4. Order for S1 to S2 is released in period 5, so that these orders are delivered to us in period 6, and then in the 7th period we will assemble S1, S2 to make P1, and finally in the period 8th, in the beginning of the period 8th, we will be able to deliver 50 P1. So, this is the way my material requirement planning is happening. We have time dimension, that how systematically if we release all the orders in the beginning, it will create huge problem, because it will create the problem that they will not be able to understand, and they will create extra inventory in the system, and at the same time it will become difficult for the timelines to achieve if we are not releasing the orders at the appropriate time. If any of the order is delayed by 1 week, 1 period, it will ultimately have the detrimental effect on my final supplies, that final supply will not be possible on 8th period. It will delay the supply according to delay in placing the order in earlier periods. So, this material requirement planning therefore becomes a very good tool, with the help of which we are able to decide when we are going to place the order and how much quantity we are going to place the order. Here, let me give you one or two cautions also. In this particular example, I have not assumed any in hand inventory. I did not assume any in hand inventory, and I assumed, for the purpose of simplicity, the lead time for all these items, sub assemblies, as 1 period. But in practicality, the lead time for different components may be varied, and there may be some available inventory with you. There may be some available inventory with you. So, you also need to see that how much inventory you have in hand, and therefore, you should be ready to give order of only the balance inventory. Another important thing, there may be some constraints from the supplier side also. For example, if you see here in this diagram, there are many situations we have placed the order of 50 units only, for S1 also, for C1 also, for C3 also, we place the order of only 50 units many times. It is quite possible that supplier may say that, hey, I am not going to give you the order of just 50 units, you need to place order of let us say minimum 100 quantity, and we have this situation that there may be some minimum order quantity prescribed by the suppliers. So, MOQs are also important thing in giving the order quantities. I have not taken any kind of restriction to explain you the formation of MRP, but I am giving you this indication, caution, that in practicality those limitations will also be there, and we have to operate in that realistic environment with a lot of restrictions. We come to end of this particular video, and in our next class we will discuss some of the important ways through which you can place your order. Means every time you cannot place the order of the same quantity which is required. There may be different kind of restrictions, and how many those restrictions are there, and whether following those restrictions are any benefit to us or not, that also we will discuss with the help of profit calculations. So, with this we come to end of this video. Thank you very much.